When people imagine the end of the world, they picture explosions, asteroids, nuclear war, fire from the sky. But that's not how scientists think about endings. They don't ask how humanity disappears. They ask something much quieter. When does Earth stop being stable enough for us to live on it? Because the world doesn't end all at once. It doesn't collapse in a single moment. It ends in stages, unevenly, quietly, and long before the planet itself is destroyed. And the unsettling part is this. Scientists already know the order. What the end of the world actually means. Most people use the end of the world as if it's one thing. It isn't. There are four very different endings people confuse. The end of civilization, the end of humanity, the end of life on Earth, the end of the planet itself. These do not happen together. Civilizations can collapse while humans survive. Humans can disappear while life continues. Life can persist while the planet changes completely. Understanding this difference is the key to understanding how the world really ends. The first thing that ends isn't life, it's stability. The world doesn't end when everything dies. It begins to end when predictability disappears. Stable seasons, reliable rainfall, consistent temperatures, dependable food systems. Human civilization exists inside a very narrow environmental window. We don't need perfect conditions. We need consistent ones. When climate systems become unstable, societies feel it immediately. Crop failures, water shortages, infrastructure stress, political instability. Nothing dramatic happens all at once. Life goes on, but it gets harder year after year. Why collapse happens before catastrophe? Civilizations don't collapse because of one disaster. They collapse because systems fail faster than they can recover. A drought doesn't end a society, but a drought followed by food shortages, followed by migration, followed by conflict often does. These are called cascading failures. Each system depends on another. Energy depends on infrastructure. Infrastructure depends on governance. Governance depends on stability. When one breaks, it strains the rest. The world doesn't end with a bang. It ends when recovery becomes impossible. Why humans are more fragile than nature. Earth has survived far worse than anything humans are causing. Mass extinctions, ice ages, volcanic winters, meteor impacts. Life adapts. Humans, however, depend on narrow temperature ranges, predictable seasons, stable coastlines, reliable ecosystems. We don't adapt quickly. We build systems instead, and those systems are fragile. This is why the planet can remain alive, even as human civilization struggles. The point of no return. There is no single moment when the world ends. There is a moment when reversal stops being possible. Scientists call this a threshold. The point where a system keeps moving even after the original cause slows or stops. Ice sheets, for example, don't immediately refreeze once temperatures stabilize. Once enough mass is lost, gravity and heat do the rest. After that point, change becomes self-sustaining. Permafrost releases methane. Melting ice exposes darker surfaces that absorb more heat. Warming oceans lose their ability to store carbon. None of these processes look dramatic on their own, but together they form a chain that no single policy or technology can reverse quickly. Everything still exists: cities, oceans, ecosystems, but they no longer return to balance on human timescales. The world doesn't disappear. It simply moves forward without waiting for us. Why Earth itself is not dying. It's important to understand this clearly. Earth is not fragile. The planet has endured impacts that reshaped continents. It has frozen over nearly completely and recovered. It has warmed far beyond anything modern civilization has experienced. Plate tectonics continue regardless of climate. The magnetic field still shields the surface from solar radiation. Volcanic and geological cycles operate on timescales far longer than human history. What's at risk is not Earth's existence. It's the narrow band of conditions that allow complex societies to function. This distinction is often lost in public discussions, but scientists never confuse the two. Earth will not break. It will simply change, and it won't check whether we're ready. The inevitable end of habitability. On geological timescales, Earth's future is already written. The sun slowly grows hotter as it ages. That increase is subtle, but relentless. Over hundreds of millions of years, rising solar energy will intensify weathering, reduce atmospheric carbon dioxide, disrupt plant photosynthesis. Eventually boil away the oceans. Long before Earth is destroyed, it will simply become too hot to support complex life. This isn't speculation. It's basic stellar physics, and it reminds us of something uncomfortable but grounding. Habitability is temporary. Every planet that hosts life does so within a window. Earth's window has been unusually long, but it is not infinite. Why this is not a fear story. When scientists talk about endings, they don't speak in panic. They speak in probabilities, thresholds, and timescales. Fear-based narratives focus on sudden destruction because they're emotionally powerful. But they're also misleading. The most dangerous changes aren't shocking. They're gradual, because people adapt to each step. Sea levels rise centimeter by centimeter. Temperatures increase fraction by fraction. Systems strain quietly before they fail publicly. Understanding this doesn't make the future hopeless. It makes it legible. And legibility is what allows planning instead of panic. What this means for us now. The most important insight from all of this isn't cosmic. It's practical. If stability is what ends first, then protecting stability matters more than preventing extinction-level events. That means food systems that can tolerate disruption, infrastructure designed for extremes, governance that anticipates stress instead of reacting to collapse. The future isn't decided by one catastrophe. It's shaped by how long societies can absorb shocks without losing coherence. Time is the real buffer, and understanding systems is how time is bought. Why this connects to everything we've seen. Extreme cold shows us where humans barely survive. Extreme heat shows us where survival becomes impossible. The deepest parts of the ocean show us where life adapts without us. This video completes the pattern. All of these places reveal the same truth from different angles. Human civilization exists inside boundaries we didn't create. Geography sets those boundaries. Physics enforces them. Biology adapts or doesn't. When those boundaries shift, the planet doesn't negotiate. It responds. The quiet end. No one expects. The most dangerous endings are not sudden. They're quiet. People adjust to smaller harvests. They normalize higher temperatures. They rebuild after storms until rebuilding stops making sense. Collapse rarely looks like a single moment. It looks like systems slowly losing the ability to recover. When connections break faster than they can be repaired, the end has already begun. Even if daily life continues. The world doesn't end when everything stops. It ends when things stop working together. The end of the world is usually imagined as a single event. A moment where everything stops, but science tells a quieter story. The world doesn't end when the planet breaks. It ends when the systems we depend on lose their balance. Earth will continue to orbit the sun. Life will adapt in ways we can't control. The planet itself will endure. What's fragile is the narrow window that allows modern civilization to exist. That window is shaped by geography, climate, and time, not intention. Understanding how the world ends isn't about predicting doom. It's about recognizing limits. Because the future isn't decided by one catastrophe. It's decided by how long we remain compatible with the planet we live on. And that question is still unfolding.